we continue from where we stop, we're able to actually find the differential of product to function, and we saw that handling different kind of product to functions. Now let's look at this. Suppose that you have your y to be equal to, let's say, function of another function. That is a function conceived in another function. Can we find the differential? Yeah, of course, yes, we can. And with that, we're going to handle it one after the other. And for that, let's start with that. Let u be equal to g of x. Now, if u is equal to g of x, from there we have u with my changing u will be equal to x with changing x, where my changing u, just like changing x, is infinitesimal increment on u. And from there we have u changing u to be equal to, that's g of x with changing x minus u, which is something as changing x. So take note of this. I can call this there. So now let's move further. And with that, if I write that, so I have y equal to a function of u. And from what we've established before, our dy du will be nothing but the limit as changing u approaches 0 of our f of u with changing u minus f of u, all dividing changing u. And with that, what's my use? You can write that f of g of x plus, so if you use this, so that's g of x into bracket, and write that properly. So g of x plus changing x minus, that's f of u, that's f of g of x. We have that divided changing x. Now changing u, which is time changing x for g of x with changing x minus g of x. So we have this to forget, limits as changing u approach 0. Now if I come back here, if limit as changing u approach 0, now what this implies, I'm using this, is that my g of x plus changing x also is approaching g of x, and that will only happen, which implies that it means our changing x, it's approaching 0. So as such, what do I do? Could equally write as limits as changing u, which is by implication changing x approaching 0, of, now what I have original, which is f of g of x with changing x, the minus f of g of x. Now I'm going to do something interesting. Now I can write this as divided changing x times changing x over g of x plus changing x minus g of x. Now what I just did here is I introduced this. Now it's more or less I've not introduced anything because it can't start eventually, but it's because of what I intend to achieve. So we have dy du to be equal to, now what do we call this? This is more like you differentiate this expression with x. So that's your dy dx. Now times, just like saying dividing, because if you have this swap all over, the limits this changing as approach 0, that's your the g of x, that's as though you're differentiating with respect to x, that would du dx. If I write that, we have my dy dx to be equal to dy du times du dx. Now take note of this. You continue from there.